a all squared plus y minus b all squared equal to r squared. So if we don't make any assumption, what we have to do first is to substitute these coordinates here, both pairs of coordinates, into this equation, okay? So that we can end up having two equations, right? So the first equation, we can get it by substituting x equal to 5 and y equal to 7. And you get 5 minus a all squared and 7 minus a all squared equal to r squared. If you simplify this, you get 25 minus 10a plus a squared. Please be aware that if you want to simplify this, you use FOIL. You use what? FOIL. You use FOIL. Also, to simplify this, you use FOIL. You simplify that, you get 49 minus 14b plus b squared. Now, just as a shortcut way of how I get that without doing FOIL, what you do is you square this first term. It gives you what? 25. Then the middle term of the trinomial, because remember I told you about what I call perfect square trinomial. So if I simplify this, I must get a trinomial. Okay? So the middle term now, you multiply the first term and the second term, you get minus 5a. And then you multiply by 2, that product. It gives you minus 10a. If you don't want that, then go via the basics. Using what? FOIL. Then the last term, it will be the square of the second term of the binomial. You get that. So we do the same. Because there is no mark allocated for using FOIL. You understand that? There is no mark allocated. But if FOIL is going to help you to get the correct trinomial, then do so. If you decide, just to clarify this, if you decide to use FOIL, say for the first one, 5 minus a squared. If you use FOIL, this will be 5 minus a times 5 minus a. Please, 5 minus a all squared is not equal to 5 squared minus a squared. Please, it's not. Okay? It's not. Right? So I don't want to see someone, if you see a question like this in the near future, then you just square the 5 and then you square the a. You say, that's your answer. No, the answer is not a binomial, it's a binomial. Alright? So we are here now. Then we can simplify this equation and we can rearrange the terms. So we can end up having a squared minus 10a plus b squared minus 14b plus 74 equal to r squared. So we can call this equation 1. Alright? We can call it equation 1. Then we need a second equation. In actual fact, if I were to ask you here, how many variables do we have in this equation? How many variables do we have? 2. Is it 2? Is it 3? Or rather, okay, alright. Let's not call them variables. Let's call them constants. How many constants do we have in this equation?
What do you mean?
We don't have. A constant is a value which doesn't change. Is the radius a constant?
No.
The radius of a circle does not change. So this r here is a constant, right? Can the coordinates of the center change? Well, okay, at this stage, the values of a and b can change, okay, but the radius can remain what? The same. But if you change, okay, in this case, if you change the radius, you can also keep the point there. The center, the what? The same. You can make the radius longer, you can make it what? Shorter. But in this case here, our main constant is going to be what? The radius, right? If you go back to the original equation here, this x and that x, they are variables. They are variables, right? And your radius is going to be a constant. All right? So let's carry on. Then we need to substitute the coordinates of that point. So we do the same as we did in the first equation. To get the first equation, substitute x equal to minus 1 here, substitute y equal to minus 1 there, you get that. Then you use FOIL, right? Or you can just simplify the brackets. You get 1 plus 2a plus a squared plus 1 plus 2b plus b squared equal to r squared, right? Okay, so we end up having our second, okay, this one here, you can call it the second equation, that one there. But if you look at our two equations now, we have got r squared on both sides, right? We have got r squared on both sides. Now, we don't want three unknowns. Okay, we have got two equations and three unknowns. Therefore, we have to eliminate r squared by equating the left-hand side. Okay, so you equate the left-hand side to eliminate what? R squared. Then, if you do that, you equate the left-hand side, you will get this, right? You get a squared, which is this one here, minus 10a plus b squared. So the left-hand side of the first equation will be on the left-hand side. The left-hand side of the second equation will be on the right-hand side. The good thing is that some of the terms are like terms. So this a squared cancels out with that a squared. Alright? The b squared cancels out with the b squared. Alright? So on the left hand side, you'll be left with minus 10a, okay, minus 14b plus 74. On the right hand side, you'll be left with 1 plus 2a plus 1 plus 2b. Alright? So let's move on to the next page. Any questions so far? Any question? Yeah, it's a one. Just like that. Probably the way that I wrote it. But this is the one. Okay. That's equation 1. Then we've got equation 2. Okay, so from the last equation, I can end up having one equation in terms of A and B. Okay? I can end up having one equation in terms of what? A and what? B. Alright? So let's create that equation. So let me just write down the new left-hand side. So we have got minus 10a minus 14b plus 74 is equal to the right hand side. I can add the 1 and the 1, I'll get what? 2. So I'll get 2a plus 2b, 2a plus 2b plus 2. Okay, so that's my new equation. Alright? Now I can rearrange the terms here, add the like terms and simplify. So what I can do here is take since this 2a is positive, I can take the minus 10a to the right, and I'll get 12a on the right. I can also take this minus 14b to the right and add it to the 2b, I'll get 16b. And then take the 2 to the left, subtract it from 74, so I'll get 72 is equal to 12a plus 16b. Then I can call this equation what? 3. Now I've got two unknowns. The next question will be, if I want to solve for two unknowns, I need a second equation. The number of unknowns determines the number of equations you are supposed to create. Okay? So, make sure you pay attention. If you are looking down, you can miss this out. Now, if I want to create the fourth equation, which I'll use together with equation 3 to solve for A and B, it means I have to use the fact that the center is along the straight line. The center. And what are the coordinates of the center? It's x is A, y is equal to B. I'm going to repeat this. But let me show you the sketch here. I've got a nice diagram here. So this is our straight line. Okay? Y equal to x plus 1. That's the straight line. This is the y-intercept, that's the x-intercept. Right? So what the question is saying that the center is along this straight line. Okay? It's most likely to be in the first quadrant. Right? I'll show you why after I finish. Right? So if I choose a point along the straight line, like say this point here. Remember, at this stage, we don't know the coordinates of the center. So we can't give a specific value to A or a specific value to B. We are supposed to calculate those values. So let's say the center is here. It means X is A and Y is what? Is B. Do you agree with me that I can substitute this A into this equation, the B into that equation? Because the point is along the what? The straight line. You agree with me? Right? If I substitute those two, we will end up having a new equation. That equation, remember, y is equal to x plus 1. But at the center, y is b. Sorry for that. Sometimes it happens, technology sometimes can cause issues. It's good that things can get there. So b is going to be equal to a plus 1. Okay? Are you following that? So this becomes equation 4. Okay? Right. It's gonna become equation 4. But we no longer need equation 1 and 2 anymore. Because equation 3 incorporates equation 1 and what? And 2. Do you understand that? Huh? So stop worrying that you have got equation 1, 2, 3, and 4. 1 and 2, they are incorporated into equation 3. Now we can start smiling. We are now in grade 10, simultaneous what? Equations. All right? And please be aware that your knowledge of simultaneous equations, both from grade 10 and grade 11, is required when you're doing analytical geometry in grade 12. So here, b is a plus a, so I can substitute where there is b there, I can put a plus a. So I can say, therefore, 72 is equal to 12a plus 16 times a plus 1. If I simplify this, I'll get 72 equal to 12a plus 16a plus 16. Then I have to take the 16 to the left. It will give me 56 here equal to 12a plus 16a, that's 28a. Right? Then divide both sides by 28. So 2 is going to be equal to 8. Which is the answer we got yesterday with the method that we use of assuming that. Right? Then to calculate b now, we just substitute the a here. So b is going to be equal to 2 plus 1, and that will give you a 3. Okay? All right? Now, the next question will be to calculate the radius. So what this means is our center is going to be at x equal to 2 and y equal to 3. Okay? Our center is going to be at x equal to 2 and y equal to 3. Alright? Then the next thing is to calculate the length of the radius. Now, to calculate the length of the radius, we can just use any one of the 2 points on the circumference. Okay? So I'm going to use, okay, can I carry on? Yes. So I'm going to use the coordinates of the center together with if I use the coordinates of the center to calculate my radius is going to be, if I use the first pair of coordinates, it's going to be 5 minus 2 squared plus 7 minus 3 squared. And this will give you the square root of 3 squared plus 4 squared. And that will give you the square root of 25. Alright? So your radius is going to be 5 units. Okay. So what this means is, in general, our equation, we're supposed to just determine the radius and the coordinates of the center. It means the equation for this circle will be x minus 2 squared plus y minus 3 squared is equal to, well, 5 squared is 25. Please be aware that we can write the answer as 25, we can put 5 squared. Alright, it's the same thing. Okay, so that would be the equation of the circle. But the question was not asking for the equation of the circle, I'm just adding this. The question was asking for the radius, right, and the coordinates of the center. Alright?
Then why did you say you had to not incorporate
What?
I'm asking you, like, why did you say that you had to not incorporate the equation? You know the y equals x plus 1?
Yes. The reason why we had to use this equation y equals x plus 1 is because the center of the circle is along the line y equals x plus 1. The center of the circle is along the line y equals x plus 1. Therefore, the coordinates of the center can be substituted into this equation. Okay, then if the center was not along the line, we cannot substitute. But for this question, we were told here that with its center on the line y equals x plus 1. The center of the circle is along the straight line. Therefore, if we want to determine an equation in terms of A and B, we can substitute the coordinates of the center into this equation. Because the center of that circle is along that straight line. So the coordinates of the center of the circle, they obey this equation here, y equals x plus 1. So if we put here y equal to 3, if you put x equal to 2 here, 2 plus 1 gives you what? 3. And the y is 3. Yes?
So can you use the second method?
What do you mean?
Like the x squared plus y squared plus r squared wasn't the same thing?
No, you can't use that because our center is not at the origin.
Oh, okay.
Our center is not at the origin. Okay, then but wait for a question.
So would we get a question like this?
Well, generally, hey, can you pay attention? Pay attention. Okay, generally, when you get your question in examinations or even your June exam and so on, we give you the diagram. Okay? Now for this question here, it's okay, it's a question from a textbook. I wish they'd provided a what? A diagram to make the question a little bit easier. But there was no diagram. And that makes things slightly more complex. Okay, but I want to show you something very interesting here. I'm not sure whether I told you this. Some of it's like a tag. What? I don't understand some of you. Look at where they're sitting. A lot going on, like what? Okay.